Hello everyone, and welcome to the Teradata and Tableau software sponsored webcast, Digital Disruption, Big Insights from Big Data. I'm John Hines, Director of Digital Media and E-commerce Marketing at Teradata, and I'll be hosting our presentation today. Before we begin the presentation, I'd like to bring your attention to a couple of areas in the webcast console that you're seeing. There is a Q&A module or widget there. I encourage you to ask questions as they come to mind throughout the presentation. We'll address some of these questions at the close of the presentation or certainly via email afterwards. So please remember to submit questions at any time. There are also some icons at the bottom of your screen to explore. There's a resource links icon that will allow you to learn more about big data and digital marketing analytics. Share icons that will allow you to send it to a friend or push via social vehicles, and then the ever-important help button with the question mark there for assistance with any technical difficulties you might experience. You can also press F5 if you're on a PC to refresh your console at any time. Additionally, we will be sending you links to additional resources and our webinar replay in a follow-up email. What makes today's webinar unique from other big data discussions is that it is specifically addressing digital marketers who are either people on the business side who are trying to better understand and influence online customer behavior, or the IT and business intelligence people who support those marketing efforts. Some people on the call here have a lot of experience with analytics, data warehousing, and business intelligence, and others are just starting this exploration. Either way, know that this is an area of the business that is poised to gain the most from big data, and yet often understands it the least. Well, we're here to change that both today and in future webinars on the topic. So we've lined up two outstanding speakers today. First, we'll hear from Chris Twogood, Vice President of Product and Services Marketing at Teradata, who will help answer some of the big questions. What is big data for digital marketers, and why should they care? Then we will hear from our special guest, Tom Fastner, Senior Architect with eBay. Tom works on the architecture of eBay's industry-leading analytical platforms and will share real-world insights on how big data is used, stored, accessed, and visualized there to improve eBay's outstanding customer experience and profitability. Finally, we will go back to Chris to discuss the overall analytics framework for accessing and using big data and how it all fits together for business benefit. So Chris, you first. Welcome, and thanks for participating with us today. We have a lot of attendees just waiting to hear what you have to say, so let me turn the floor over to you.
All right, thanks, John. What I'm going to talk about today is really looking at what's going on in today's society. I mean, today in our society, we generate as much data in 2 days as we have in the past 5,000 years. That's over 5 exabytes of data. And that just means there's oceans and oceans of data that needs to be analyzed. And so we have data everywhere. And consumers are using this data to empower themselves to really understand buying behaviors and product trends. They're talking to us about their likes and dislikes, but they're also talking to other customers and influencing customer behavior. The challenge is, though, is that marketeers are just overwhelmed. There are so many new digital marketing metrics that they have to deal with. They got to look at email and search CTRs or click-through rates. They look at the number of unique visitors, new versus repeat visitors. What about site conversion rates? And the problem is they just don't have the analytic tools to help them really analyze this information. Today, typically, they have site metric tools like Omniture or Web Trends, T-Leaf or Google Analytics. The problem with those is the channels are reported on separately. There's really no specific customer historical activity, so they can't understand the trends in the customer's buying behavior. They don't understand who their customer is. There's kind of aggregate and rolled up information. And it is very labor intensive to monitor all that information manually, and in a lot of cases get that information from a software as a service model into the corporate information infrastructure. And it's also not very predictive. And what marketers really need is this idea of having a complete cross-channel view of all of the different information. Not having that cross-channel view means that they're making suboptimal decisions. And it feels a lot like best guess marketing, Are they just guessing, or are they doing it based upon their gut feel? How do they feel today? Is this a good thing? Is it a bad thing? Marketers are not using data and analytics to really make the best decision possible. If you look at what big data for digital marketers is, it's more than just clickstream path data. You want to understand pre-visits, on-sites, post-visits. You also want to have all your social media and customer input information. You want to have your customer interaction records from all of your different cross-channels, including phone, retail, web, email, direct mail, banner, search, as well as all of your different machine-generated touch information through sensors. But typically, all of this data is very messy. It's too big, it's very disconnected, and you really want marketers to be able to understand what are the nuggets inside all of this big data. What is the value, and what is it that they're missing in order to make good decisions? So what if you could really think about what does big data mean? And it's really about this evolution from transactions to interactions. Megabytes was really delivering a set of data, more transaction information, normally generated by ERP systems. And then we moved into more gigabytes with CRM information and segmentation and offer details. And then terabytes really when we started looking at web logs. But really this idea about moving into petabytes and big data is really bringing in all this other information, sentiment analysis, mobile web, HD video, speech to text. So what if you could take all of this big data and easily track and report really every single interaction that a customer has with you, regardless of channel, time, interaction, or outcome? Where did they first start when they touched your business? Where did they go into the next 3 steps? What channels do they use? And then if you could take that information and then really analyze that and analyze those patterns across really hundreds or millions of different customers, it will really enable you to understand what are the best paths for being able to determine the optimal outcome. In being able to do that, you could then do all kinds of very interesting things driving towards competitive advantage. You could drive activity-based costing. You could execute information in the right time to the customer based upon their needs. You could really drive very personalized interactions with all of your prospects and customers. And really automate a lot of these different processes and drive towards really a true one-to-one e-marketing model. What I want to do now is turn this over to Tom and really look at real-world examples on how eBay is getting big insights from big data. Tom?
Thank you, Chris. Well, welcome to my section of this webinar, talking a little bit about what we are doing here at eBay with big data or in general with data. So at eBay, when I joined, I thought, well, what do we need those thousands of people for just to run a website? And soon enough, it got really clear, it's a very complicated and intermingled business. And, at the end of the day, data is all we have at eBay. We don't own the products. We don't ship the products. We don't do anything like that. All we do is provide a platform for people to do commerce. And so in my talk, I will try to explain to you what are the kind of things we do here. How does the business of eBay link to the analytics we are providing here as part of the analytics platform and delivery team. And then talk about the platforms itself. We have a stack of 3 of them, walk you through a couple of use cases, and then highlight the differences of those platforms as we see them right now. And then I'm going to close with how do we get to the last mile? How do we get all this data and all the insights into our user community? So it all starts with, real estate. Product management owns features and owns sections of our website. And this is a screenshot from a couple of weeks ago from the homepage, which is changing all the time. And the product managers are negotiating how much space they get to promote something, to introduce a new feature, and so on and so on. And you would hear endless discussions about, hey, I think I need more space to do this because I can drive more traffic to this, and we can sell and help sell more products. Without data, we will never ever know. So we built an environment that really allows us to capture what's happening on the website way below click streams and see and prove the case what is the better way to go. And so it's really a fundamental environment, and it allows us to run other programs, global programs, in the transition from this old kind of listing layout, what you've been used to when you looked at it like 10, 15 years ago, to a more product-based experience, what you can see today in several of our verticals, including a lot of electronics, like here the example on iPad, or shoes and accessory shoes and clothes, and some others like cars. So here is a completely different layout, and we need to figure out, okay, what is the best way to really surface those items? For vertical, you also need something like a catalog, right? So we coming from a history of, people are listing whatever they want, and we have no influence how they list it. Two, if you want to go to a vertical, you need a catalog. You need to somehow condense it, and try to do this across 50,000 categories is quite cumbersome, especially when some of those categories don't even have an industry catalog. We also transitioning in that away from the old kind of listing format to obviously buy it now. You can you don't have to wait for an auction to end to get to purchase something, but we also want to escape the e-commerce side and really widen our scope to commerce. So we are offering local offerings. You can find your item, and if you want to pick it up at your local store, here you find which store has it online, and you can get that site set aside. Another very, very intense analytics program was the buyer protection program. So if you purchase something, as I said, we don't own the item, we don't ship the item, we have no control of the condition of the item, but eBay is stepping up for the marketplace and protecting the buyers from a bad experience. So when the item is not as described, or it got damaged during the shipment, and so on and so on, the buyer is protected by eBay. And this is a high-risk kind of program, and there was a ton of analytics going into that over the years to shape our environment with detailed seller ratings and some other features to really gain confidence on offering this kind of protection to our marketplace. And finally, we are going across channels. So the internet channel is one thing, but mobile is gaining a lot. So we've seen tremendous success on the mobile side. eBay is probably one of the most sophisticated mobile development sites in the world. We had about $4 billion of GMV coming through mobile purchases in 2010, which was about half the market of the Americas. So we see tremendous growth there, and we also are supporting this environment with standardized reporting environment. So a developer doesn't have to really figure out how to analyze what he's coding. It's already part of a framework and available to every developer today. So now let's take a look at the platforms and the data that's coming in. So the website is generating about 50 terabytes of new data every day. So not everything is interesting to us. Most of that is really about system conditions and those kind of things we are less interested in. The big chunk of the data is probably about 7 to 10 terabytes a day of user behavior information, which is kind of an application log information. And then we have about probably a terabyte or two of transactional data. So this is your classical enterprise data warehousing kind of data that's being generated or changed every day. And by the time we have it loaded into our environments and run all the batch processes and all the ad hoc analysis that's going on there, we are probably shuffling about 100 petabytes of physical I/O on our enterprise data warehouse and the large deep systems. We see about 150,000 tables out there from eBay, and then the largest table we have is about 850 terabytes in size under RAID 1. It hosts about 2.6 trillion rows of all those little tiny events the applications are trying to log. Our batch environment is fairly complex. It's been growing over the course of 12 or 13 years, and it's bigger than 55,000 batch streams of logic that is getting the data from more than 500 Oracle databases from the site being loaded into the EDW or some other way we're going to see later, and get that data in place into staging tables, into working tables, and finally apply to the final targets. We see about 7,500 users named on the analytics platforms, and they are running millions of queries a day, and we do not want to restrict them to anything, so everybody can actually do ad hoc exploration on our data without being restricted by pre-canned reports. At the same time we're running batch, we're running online, we also do backups, and we can do somewhere between 10 and 38 terabytes per hour, depending on the system we are backing up from. So how do we do that? What are the platforms we have in our toolbox? So it all started somewhere in the 2003 timeframe with the enterprise data warehouse. Since then, we've been growing about 100% year over year, and today our main enterprise data warehouse is about to be upgraded to 98 node 6690. So it has about 10 petabytes of storage. Over half a petabyte will be actually SSDs. And this is the place where you see all the structured classical enterprise data warehousing coming in. It's the enterprise class warehouse, enterprise class systems, enterprise class hardware, and it shows certainly the best availability, the strongest governance, and also the largest user community. It drives the most concurrent workloads, and this is the place where you're going to do the analysis and reporting for the enterprise. As a DR system, we are using actually a 1600 platform in the near future, and that will be good enough to be a standby DR system. 4 or 5 years ago, we got challenged. That was about the time frame I joined eBay, with loading back then 5 terabytes of new data every day. These were the application logs that existed on an ab initio cluster, and you needed a developer to get access to it. And to put that on the enterprise data warehouse would have been too expensive. And we worked with Teradata and came up and supported probably the appliance kind of development. And we came up and using today a 1650 generation hardware to load the data. And actually, we are loading the data, and given that the data is changing in a data model from a data model perspective every day, every minute, we are loading that into a special form that is not fully normalized. So a couple extra functions have been coded to allow us to take the pieces apart and put them back together so we can actually make it work in a relational database. So the semi-structured information we are accessing with an extended SQL environment. We added several functions to that allow us to do analysis on this. In order to really make it feasible from a budget perspective, we needed to go to an appliance, so a low-end enterprise class system. And today, this is the largest Teradata system in the world. So it's 256 nodes of 1650s. There we have like 36 petabytes of disk storage behind it, and about a little bit north of 500 million physical CPU seconds per day. We're going to talk about mostly later on this system how the data looks like and how it's being done, and because this is really the site where a lot of the big stuff is happening. The latest addition to the stack is the unstructured world, is Hadoop. So in 2010, we started looking first time seriously about Hadoop, and by the end of the year, eBay was the third largest Hadoop site in the world. Today we have 2 major production clusters. Each one has about 20 petabytes of storage behind it, and it's somewhere between 1,000 or 2,000 nodes today. So here, this is the new wave. This is what really brought up the big data topic. This is where you need developers in most cases that are coding Java and C programs to access any kind of data. It can be structured, semi-structured, unstructured. It really doesn't matter. It is built on very commodity hardware usually, and it's built, to really handle fallouts. Some of the nodes will be out of the configuration most of the week, and you go in and repair it once in a while. Very different model. So if you look at the configuration of those systems from left to right, you will see the major difference between them is really in the ratio of CPU power and I/O throughput. So the enterprise class system, so 6690, has probably the equivalent of 300 hard drives, given the mixture of SSDs and hard drives. A Singularity system is only a fifth of that. It has only 72 disk drives behind the node, and Hadoop is even less than that. So we see like 12 disk drives behind the node. And this is the major limiting factor in this kind of environment that drives the significant difference in the concurrency. As you can see on top of the slide, on the EDW, we see probably 500 or more queries running, ending, or starting within a minute. On the Singularity system, we see a significant difference. It's only 150. And on the Hadoop side, we probably see something between 25 and 50. It can obviously peak in any one of those, but this is what those platforms can deliver to the user community. So now let's take a look at what kind of stuff are we running on each of one of those. The Enterprise Data Warehouse is hosting one of the key applications, which is called the Keyword Data Mart. So keywords is the stuff people type into our search box. And one of the things we do is we're going to bid for those keywords at Google and Yahoo and Bing to have them pop up in paid search. So there's significant benefits to the company, and this is quite a big application. So it's 170 million different keywords. We are figuring out every day how much money we want to bid in order to come out in position 1, 2, or 3 of the search. And we can run promotions, and there's a lot of massaging going into that data, into hundreds of tables, trying to figure that out. And the key thing also is it got to be done at a certain time so we can actually deliver our bids to our partners. Because if they can't receive it in a certain time, we will miss this opportunity for the day, and they will continue using that from yesterday. On the front-end side, we have probably 150 users using a MicroStrategy-based environment to keep track of all those bids, of all the programs and all the promotions they are running in this environment. So it has a very high SLA, got to be done at whatever 7 or 9 o'clock in the morning, and it is mostly based on structured information. It got extended by additional application level log information we host mostly on the Singularity's platform, but this is an aggregation table, so that gets shipped over to that environment. On the Hadoop side, the other end of the spectrum, there you have a lot of flexibility what kind of data you can load into this environment, because all you have to do is land files. And then you write your little program to go through those files and find out what you want to do. So one of the first success cases was identifying duplicate listings. In 2010, eBay dropped the listing fees. And what happened if somebody had 100 batteries, they would not list it anymore as a multi-quantity item. They would list 100 batteries separately. And if you are a good seller, your items will pop up on top of search. So you will dominate the first 2 pages of search. Now that's good for the seller, but it's a lousy experience for the buyer. And we wanted to look into that and identify duplicate listings and encourage them to list it in some other way with the multi-quantity items. We didn't know what to expect. We didn't know what really determines duplicate listings. So we looked at description of the item, we looked at pictures of the item, and so on and so on. And at the end of the day, there were like 15 different attributes that determined, okay, this is a duplicate listing, and let's take care of this. But shortly after that, people will find out, and they will play the system. So suddenly you see, like in the screenshot, there are numbers that are different in the item title. So now you're no longer looking at an equality join. You're looking at some fuzzy logic to compare almost identical strings, and sooner or later they will find out they can change pixels in the pictures, and they will stay under the radar for a while. So Hadoop allows you to react to that fairly quickly and pull in new data sources to do those kind of more complex analytics. Also, another big use case for the Hadoop side is natural language processing. Think about what people are searching for, item descriptions, trying to figure out, okay, how do I take the item description, the title apart, and figure out what part is it and find it in a catalog so I can actually put that into the right places. So these are the kind of things we do on the Hadoop side. The Singularity piece, as I mentioned before, was built to actually collect and store 2 years of history of our application level logs. So nowadays we are storing about 7, 8, or 9 terabytes per day, depending on the day, and adding it to our tables. And the key application we are doing there is A/B testing. So whatever we change on our website can have significant impact to our business. So we want to be really careful. So as a screenshot you see here, 2 versions of the same website. The left one has smaller pictures than the right one. Everything else is the same. And these are the kind of A/B testing we are doing. And we are doing those for about 100 different use cases at the same time in production. So you as an eBay shopper or browser, you're going to see potentially different screens and get different treatments depending which customer bucket you're in. And in the back end, these kind of treatments and experiences are being logged in those log data, and then being analyzed on a daily basis. And those experiences run for 4 weeks to get enough data and really make sure we are doing the right thing before we actually push this layout across our user base, usually by country, usually by feature, and so on and so on. So this is the major use case there. It's all semi-structured information, and how this works now is in the next couple of slides. So the data is coming from the application servers. They are logging their stuff. They are publishing the data on the typical bus, which is called the central application logging here in the picture. And this is where we, from analytics, actually pick it up with listeners. So we are only listening for the user behavior information. We are not listening for the system health kind of information that's also being published there. And we load that through a server farm into our Singularity system, where we do hourly or daily bot detection processes. And but the key thing here is within about 2 minutes, the data is being loaded into the Singularity box. And within like 10 minutes, somebody could have access to it if they wanted to. So most of them are really happy with the data from yesterday, but some of them can have the ability to look at that within 10 minutes from the site. We are talking, as I said, maybe 5,6,7,8,9 terabytes today, which translates into somewhere between 55 and 110,000 messages per second. So how does the data look like? So what we call semi-structured is really, we identify the most frequently used data elements like you see here, start date, GUID, session ID, and page ID. But then we also have this semi-structure where we try to pack all this variable stuff in, and we're going to use, in most cases, name-value pairs, and we concatenate those with ampersands. So in this case, you see here the language is English on this browser, and source is HP, and then you have an item list. So let's take a look at that and see, what does a query have to look like to figure out how many items surfaced in a day and how often. So it's a two-step process. So we're going to take a look, and the first thing we have to do is pick out those items, this item list. So for that, there's a name-value-list function. So this is a simplified syntax, by the way. But it's a name-value-list function that will pick out those 5 items and the intermediate result you see on the bottom of the screen. If you take this now and feed that into a table function that will actually take the list and pivot that and make out of this 5-item list a 5-row table or a spool file, we call this normalized list function. And there you have it in a form that is actually digestible and usable very well for a database. So now if we run this fairly simple query over our event table, so it's about somewhere north of 4 billion rows per day we have to go through. So we have to scan those 5, 6, 7, 8, 9, 10 terabytes, depending on what time frame we are looking and what day of the week we are looking. Going out of a 2.6 trillion row table, which is somewhere about 4 petabyte. If it's uncompressed, it's probably 800 terabytes compressed today. And the business side has like 40 billion search impressions per day, and there are like 10,000 different tags in there, so one of them just happens to be this item list. If we run this for one day, it will surface about 135 million items that have been shown in any search results, and the most frequent one might be 70,000 times. And this will come back in 32 seconds. So it's fairly efficient, and the runtime of those simple analytics queries is really determined by the time, how fast can you scan the data. So what are now the benefits of this semi-structure? The way we see it, it goes through the whole process. It starts with data modeling. We don't need to model those 10,000 different tags into hundreds of different tables the way you have to look at it from a business perspective. So it simplifies your modeling perspective, and you don't have to worry about changes in this model because you will always store it in a container, in this case a varchar field. It also helps you with ETL, because you don't have to pick it apart anymore. You're just loading one table. It will be faster. It's not vulnerable to changes again. And it will actually compress fairly well. We see an 84% compression rate on this event table. And finally, in the processing side, I can look at that thing, and the data is already pre-joined. So I wouldn't have to go out and join again to the other tables I have built. It's already in there, and it allows me to do some interesting functions with the data as well. So we see tremendous benefit, and I think this is applicable to a lot of other data out there. Even things like cars, right? Cars has a lot of electronics that will get new sensors every day, and the sensor will send you different data. But as long as you save and store this information in a more generic way, it doesn't really matter what kind of sensors are sending you data. Right? You don't need to know what kind of value they are sending you. So we see tremendous value out of this. And one of the key central topics on those environments is really compression. Since all the Singularity system, so the 1600 and even the 2600 platform or a Hadoop system have less I/O, compression is key to success. So you're willing to trade CPU power for I/O throughput. And you will see different compression rates. As I said, we are lucky on the event table. We see like 84% compression. But your mileage will vary depending on what kind of data you're loading there. And we see tremendous throughput gains, but what you will not see necessarily is that the jobs will run faster, right? You need to understand these kind of things. Now, if we summarize this, okay, how can we compare those platforms? What should I do if I have a project and I need to figure out where should I go? So one of the first exercises we did last year is figuring out a model that allows us to say, Hadoop is not for free, right? It does good stuff and it can do anything, but even whatever the EDW does and whatever Singularity does and probably all other platforms, because you can code whatever you can code. But is this the most efficient way to do that? So what we did is we looked at our environment, we talked to the CFO and got all the financial information about hardware, software maintenance, as well as power and floor space cost in the data center. So it's really the hard cost, not even people cost. And then we said, okay, what is the standard unit I have to put a price on? So for Teradata systems, it's amp CPU times. For Hadoop, it would be slot seconds that were identified as being the critical resource. And then you can run tests and say, okay, now if I do a table scan and summation in this case, how many units of parallelism do I need? And then you can multiply this out by the cost. And funny enough, in this specific case, Hadoop, to run this query on Hadoop was as expensive as it is on the enterprise data warehouse for us. Now you will get different results depending on demographics, depending on how you have coded this. But as I said, this is not really sophisticated. This was just to demystify that Hadoop is actually for free and can do anything. And then, we want to get smarter about this. The market is really at the beginning of the hype cycle. So people are a little bit unsure what are the platforms capable of doing. There's a lot of new stuff coming down for different platforms, so the capabilities will change on a very frequent basis going forward. But this is a suggested job platform affinity. So if I have a certain workload, which platform would be good to run this on? And so if you look at large-scale text processing, you certainly can do that on the EDW. You have more flexibility on Singularity because we added more functions, but you have complete freedom on Hadoop, right? The same similar strength for Hadoop is how can I grow my system? On the Hadoop side, I'm rolling in a rack at a time, and it will start redistributing my data, and we are fine. Very, very flexible. On a database, it's not quite as easy because you have to rehash your data. SLAs are certainly a strength of a database versus Hadoop, right? Hadoop is not necessarily well equipped for multi-tenant kind of applications and holding strict SLAs unless you want to dedicate a whole cluster to a specific function. So it will be more applicable to the enterprise data warehouse. So a couple things we discovered here. Big data, scan and group, the second to last as an example. That's something you might want to discuss about, especially around big data. It's really, you can do big scans and group buys on the Teradata platforms, but the key difference is for big data. If I want to look at 1 year of our user behavior information, I'm scanning 450 terabytes, and I would have to hold this in spool, right, as a database. On the Hadoop side, I don't need to hold this in spool. So this is a key differentiator there. But, who would look at it 1 year at a time? Maybe it's good enough to look at it 1 day at a time, which is true in most cases. These are just suggestions and observations from our side as we speak right now. Some of those criteria can be specified with data and backed up with data. Some of them are really more soft and need to be defined a little bit closer for your shop itself. But I think for this discussion, it's really just be aware there are different criteria, and the platform will have different capabilities, and your organization will have different capabilities and skill sets to actually leverage those platforms. So, but how do we get the data to the end users, right? They want to do and explore, and they want to do their own analytics any given point in time and drive value for the organization. So usually their answer is a data mart, right? I want to build my own cluster, build my own environment. I will load my own data, but it comes with challenges. First of all, the virtual data mart is empty. Second of all, I need to get data there, and I'm going to copy data all over the place in the organization. If I would centralize this in what we call virtual data marts, or Teradata calls elastic data marts, is you benefit from holding everything in one environment, and you can leverage, at the time you provision this data mart, you can leverage 1.5 petabyte for us of data. We don't have to ship anything. So it's well integrated, secured, managed, and cost effective. So comes with a warning, and these are the key issues here, right? Hardware, software maintenance cost, that's an easy one to understand, and this is not where the model breaks. The model breaks because you are creating islands, and you are restricted to your island in regards to resources. And then you also have a huge overhead of copying data around, creating unload, load processes, and then also keeping the data in sync, or fixing data issues will become an issue as well. So it has been proven here at eBay, a data mart cannot be cheap enough to really justify its existence. But when we start with data marts, we also want to provide tools to enable our users to self-service their analytic needs. So we built and integrated that into our data hub and our analytics platform that allows you to provision a data mart. You can actually grant access to somebody else. You can load data into your own tables. You can run and export stuff. And so it's all auth-friendly. It's self-service, fairly easy, and it's in production for many, many years. We have hundreds of data marts on the enterprise data warehouse, probably over 100 on the Singularity box, and the largest one for a single user is 100 terabytes. So now a little bit more about the data hub. So we're building a collaborative analytics environment that allows our users to really get together and discuss and work on analytics. It's based on Joomla technology, and it's really the idea of social, copying the idea from social websites. So you're going to see things like workspaces, like forums, and sophisticated search algorithms. So just a couple of screenshots here to wrap up my talk about how you can create a community of analytics. And you see, your regular welcome screens. You have your own configuration of your own portal environment. You see an activity stream of the community, what's going on, what are people discussing right now, what are the hot features today. If you're not on the DL for this feature in your mail, you will never know it. Here you see it coming by, and you can react to it. You can create your own mashup. We integrated this Hadoop and this Data Hub environment with Tableau. So you can actually plug in a live Tableau report into this. You can provide an explanation what you're showing there, and you can actually annotate it. So our CFO is using this environment in his staff meetings live to discuss our numbers. Search results, it's integrated search. It's reaching out to Wiki and all the other data sources we have, metadata, SharePoint, and obviously everything that's going on the Data Hub to give you a quick overview where you find the information you're looking for. You can see the data types, the result types, the trust signals if somebody liked it already because he was looking for the same thing. So all those ideas are being reflected in this environment. And it allows you to reach out to experts and discuss certain topics. It has features like formatting your SQL and other things to really make it native and intuitive to use. So data at eBay is really critical, and the company is really driving key initiatives and changing the market and changing our environment, going from e-commerce to commerce. And we figure out there's not a single system that can solve all the issues, all the problems, and all the questions we have. We need a stack of different systems, and at the current time, we are pretty happy with the stack we have with an enterprise data warehouse, with an appliance Teradata system, the 1650, and the Hadoop environment. This allows us to really get this all done. And I think what we will see is you will see a lot more tools and capabilities coming out in the near future to facilitate the data exchange between those central platforms, as well as making the data and the analytics more consumable for the users. So with that, I turn it back to Chris.
All right, thanks, Tom. So what Tom was describing, we really talk about this around the path to big data analytics. And we do this through a unified big data architecture. And if you think about this, you really need to look at how you typically think about BI, which is business users determine what questions to ask, and then IT goes in and builds structures around being able to answer those questions. And so typically, you're only capturing the information that's needed. But big data really turns this on its head a little bit. In the big data case, you capture all of the data. And then you use big data analytics through an iterative type of analysis framework to really discover information. Let the data itself tell the story. And so what you need to do in a unified big data architecture is bridge these two worlds together. You need to be able to have a SQL environment for really doing your BI framework, and then MapReduce with the processing flexibility to go against big data analytics and be able to process information very rapidly in a single pass. And so most people really need to have this unified big data architecture where you're capturing information all the way from audio and video through text, machine logs, supply chain information, ERP, capturing it, storing and refining it, just landing files, and then discovering and exploring information, uncovering new patterns and nuggets out of the big data, and then being able to share that information with the enterprise through reporting and execution. And then you want to have multiple layers in terms of how you access that information, whether it's through SQL, Java, visualization tools like Tableau, give the business users access into this unified big data architecture. So how we see this architecture coming together is really kind of Hadoop at the bottom of the framework for really doing long-term raw data storage and landing files. Teradata Aster as a discovery platform for really uncovering patterns of information within that big data. And then really, Teradata as your active data warehouse for sharing information. But you don't have to load just data all the way through just Hadoop. You could also load directly into Teradata Aster and into the active data warehouse, specifically around if you're combining with reference data. And we've got lots of different integration points between these different architectures. From a Teradata perspective to Hadoop, we've got a JDBC interface, different input and output formats. We've worked with Cloudera around Scoop, table UDFs. And from an Aster perspective, directly to Hadoop Adapter, we co-developed one with LinkedIn, and both of these provide very high-speed, bidirectional movement of data between these different architectures. But a lot of people really want to understand, when do I use which within what type of framework? And you saw Tom lay out some different structures. And so what we've done, if you look down the left-hand side, we've got stable schemas. These are transactions, things that have known attributes, ERP, CRM type systems. Evolving schemas are more, machine processes where you have changing attributes. things like clickstream analysis, where you might have long strings, but they're more dynamic because your website changes quite often. And then a format and no schema is really around images and videos, where you might be refining information to extract the metadata. And then we looked across the top and we said, okay, if you have low-cost storage and retention for being able to do long-term storage on raw information, what do you do in terms of pre-processing data for downstream processing, and then also transformations from converting structures from one structure to another, and then reporting and analytics. And so we looked at each of these different layers, and from a stable schema perspective, you really want to leverage an enterprise-wide foundation that has a very strong audit trail, and you're able to balance the books from. So Teradata is really the best platform to do this. For long-term data storage, you can absolutely use Hadoop on a stable schema if you want to. In the evolving schema, Hadoop is the better platform for long-term data storage, but Aster, with regards to being able to do transformations and being able to execute reporting and analytics. And then when you look at the format and no schema, Hadoop plays very, very strong here. Similar to what Tom was talking about, where they had duplicate listings and you want to be able to look at the images and determine are the exact same image or there are different characteristics about it. And then Hadoop plays a great role there, but you want to be able to extract that metadata and then deliver that into Aster for analytics. From a Teradata perspective around stable schema, we really do offer a lot of architectural flexibility for these spaces of low-cost retention, storage, and transformation. Our Extreme Data Appliance 1650 is what Tom was representing as singularity, and we really use very strong compression techniques, and our list price per terabyte is all the way down to 4K. So it is a very price competitive offering. We also offer our data warehouse appliance if you're doing more CPU intensive processing around transformations, and it also has automatic compression engines, and this is around 11K per terabyte. And then what Tom was talking about around our active EDW 6690 is really a hybrid architecture. We have solid-state technologies and hard drives, and you can use one of our new features in Teradata 14 around compress on cold to compress that data and deliver it and store it for long periods of time at a very low cost per terabyte. The other thing that Teradata offers is our self-service data labs, and we really model this around what eBay did with their virtual data marts. So we have data labs, which is a full viewpoint portlet where business users can control their data and can set up really virtual data marts within the Teradata infrastructure, and literally in as little as 5 minutes they can have information in there and they can start joining with production information. So it gives business flexibility, but also gives IT really user control. We recently did a benchmark on web analytics between really Teradata, Aster, and Hadoop. You heard Tom talk about a lot of the swapping that Hadoop does and the efficiencies of it. And you can see here in this web analytic, Teradata Aster is 5 times faster performant than Hadoop. And then if you look just at really simple web types of analytics, it's almost 35 times faster. So you really need to understand the performance characterization and the resources required to meet their specific needs. One of the things, if you think about Hadoop, you really need to look at what it takes to bring it to the business user. Initially, Hadoop was developed by Yahoo and used by internet companies, but there's this big chasm in getting it to the Fortune 1000 companies. From a Yahoo and an internet perspective, they're just like, give me a distributed processing framework. I've got lots of developers and engineers. I can build the queries and I can build all the governance around it. But in a Fortune 1000 environment, they need much more. They need out-of-the-box analytics. They need enterprise hardening, and really be able to leverage existing staff. And so one of our focuses around this is really to provide this framework where you can have business users access information in Hadoop. You're really bridging the science of data with the art of business. Because today, Hadoop really does have and require developers, engineers, custom code, and IT has to optimize the environment. Where if you're using technologies like Teradata Aster and Teradata, you have all the built-in optimization and distribution and self-managing of the architecture. But the challenge has been is how can I get business analysts to have access to Hadoop? And so what our strategy is really providing analytics through the SQL MapReduce framework to go directly against data in Hadoop. And we do that both through our patented SQL MapReduce foundation within Teradata Aster to be able to not only make that easier so that business analysts can access information in Hadoop through tools like Tableau, but also provide 50 prepackaged analytics and functions that makes it easy for them to deploy solutions. And so this just shows some of the different analytic foundations that we have through in-path and path analysis, sessionization, decision trees, graph analysis to understand nodal relationships. And this is really important because as you really want to do digital marketing, you want to make it easy for your business users to deploy. In addition to this, Teradata offers digital marketing optimization. Really the foundation of being able to have all of your data, bringing it into Teradata Aster, make it available and integrate with your enterprise data inside of the Teradata database, and then also use our recent acquisition of Aprimo to be able to do integrated marketing management. So we really, as Teradata, really want to work with you to really take the lead and really start capturing insight. So how do we get started, right? Everybody doesn't start at the scale that eBay is. So I think one thing you can do is really start asking deeper questions about your customers and the information you capture about them to really provide transparent data. I think also we want to be able to help analyze big data opportunities. And so we can get you in touch with an expert within Teradata and Teradata Aster to understand these different foundations. You can also start experimenting on your own. You can download Teradata Aster Express. It's a free developer version where you can take it and start loading big data and start testing out some of these specific types of analytics. So what I'll do now is I'll go ahead and turn it back over to John for Q&A.
Thank you so much, Chris and Tom. And thank you, everybody. We've had a lot of great questions come in over the course of this. One of them was directed more towards you, Chris, and that was, how exactly does Tableau support visualization of big data? And can you explain the value of that visualization element Tom touched on for those who don't know really what we mean by that?
Yeah, I think that's a great question. And Tableau is just a really great partner for Teradata, Teradata Aster. Tom uses it at eBay. The key thing is that Tableau requires really a SQL interface to be able to access the power of MapReduce. And so what we've done is we've worked closely with Tableau to be able to invoke SQL MapReduce within a Teradata Aster framework, and you can do all kinds of very interesting visualizations. You can do clustering visualization, you can do path and pattern analysis visualization, and really understand what is the noise, where's the noise, and then being able to dynamically filter it out. I think the other thing is, as I said, you need a unified big data architecture. So it's not just about using MapReduce, it's about using MapReduce in combination with SQL. And Tableau, in using SQL and SQL MapReduce, can help really bridge that gap.
Thank you. Here's another one, and this came from our friend Greg Blair over at Cisco. How do analytics users get the performance they need from data labs if it's using the same Teradata infrastructure as the production enterprise data warehouse?
Well, what's nice about the performance is within each of those different data labs, you can establish it as its own specific type of workload group. And so you can set up service level agreements for each of them. And Teradata does a great job and has some of the best world-class workload management to be able to manage your different SLAs or service level agreements required by different business users. Tom, do you want to also answer it from an eBay perspective?
Yeah, it's certainly a valid concern, and this was also the biggest concern from our operations group. It turns out that the data labs actually help you save a lot of CPU, because if you have an analyst who is trying to join 10 tables and then on top of that does some analysis, as part of his development cycle, he will run this 10-table join a couple of times before he gets it right. So if you would provide a virtual data mart, he can store the result of this 10-table join into a little tiny table and then iterate over this. So what we see is, yes, the queries running out of or into those data marts are sometimes not as efficient as you want them. But on the other hand, they are a huge potential of saving CPU cycles. And so all the regular rules also apply in workload management. In our case, they are running under their user ID, and they get the same priority as in other cases, as if they would use another BI tool or something. So it is transparent in that. The other thing we built is keeping track of the usage. So every business owner has a budget of CPU seconds they can burn in a month. And if they see somebody consuming for ad hoc exploratory stuff and development 50% of his budget, he will tell him otherwise, right? So there is some self-policing facilities here in place at eBay that allow us to manage this better. But as I said, we have hundreds of those on our systems, and it has been extremely successful.
And one more question. This is probably a little more high level, but how long does a typical implementation like this take for those who are marketing, just taking a look at saying, I want to do more with my marketing data, I want to take advantage of big data? What do they expect as far as how long it would take? Chris?
Yeah, the nice thing about big data, and Tom touched on this, especially if you're not having to go through this model where you're having to understand the business question and model the data. When you're bringing your data directly in, you can bring it directly into Teradata Aster. You can use some of the prepackaged transforms to do your sessionization, your transformation, and do late data binding directly to the analytics. So you can get up and running very rapidly in being able to understand and do discovery within that specific platform. I will say, obviously, to get to the level and scale that eBay is, that takes a while because you've got just the maturity and the ingestion rate and all the different users. But you can start very small and get great value and then expand from there. And I think that's key, especially as you're looking at big data. You don't want to go just build a big infrastructure and say, well, I hope the value is there and I hope I can monetize it. I think you can start, really understand the value, and then build on top of that within the overall framework. Tom, you want to make any comments?
Oh, I think you captured it very well.
Okay. Well, I'm sorry, everyone, we're not able to answer all of the questions that were submitted, but if we didn't answer your question today, someone from Teradata will follow up with you shortly. Thank you again, everyone, for attending. I want to make sure you know the replay link will be made available after June 1st. We'll send an email with that information. Again, the content widget on your webinar console has some resources available, links to the videos around what is big data and the